This is Ellie. It's a robot that's designed to be an assistive robot for people with motor impairments. It has two main ideas behind it. The first idea is that when commanding the robot, you can use a laser pointer to illuminate an object and therefore have sort of this clickable world. So if I click on an object, the robot will go and grasp that object and pick it up. After it's gone and picked up the object, then I can click on myself, and that means deliver the object to me. If I click on somebody else, it will deliver the object to somebody else. It's also the case that you can click on the top of a table and it will deliver the object to that table. For object fetching, you have to be able to tell the robot what object it is you want it to get for you. And right now, robots are not good at understanding language. They're not good at understanding your gestures. But they are great, we have shown, at understanding a green spot put on top of the object you want. So we think it's a really powerful new way of interacting with robots. This is a type of user interface. It's sort of like the point-and-click interface that you'd have on a personal computer, but now it's on a robot, and instead of just on this 2D screen, you have it for the 3D world that you're inhabiting. What we've done is we've developed an object retrieval application for a robot that is supposed to be a companion robot that stays by the side of the user throughout the day and can help him or her with these activities of daily living, specifically fetching objects. Most of what you see are these flat surfaces, and that's where you find objects, and the objects that are important to us. So we wanted to build a robot that would take advantage of that structure, and the way that Ellie takes advantage of that structure is by being able to move its arm and its sensors up and down. So it can move all the way down to the floor with its arm and its sensors, or it can move up to a shelf with its arms and its sensors. And for any of those different heights, it's able to use the same strategy for grasping the object that's out there. It doesn't have to change the way it does things based on the height of these various surfaces. This is a collaboration between Georgia Tech and the ALS Center at the Emory School of Medicine. And that's an important collaboration because what it allows us to do is make sure that the robot we're creating is going to meet real needs and help real people. So through this collaboration, we're able to work with patients, we're able to interview patients, and eventually we'll be having these robots actually interacting with patients to make sure that the robot meets these people's needs.